So, hey everyone, I'm Daniel Ospina. I'm head of governance at the Aragon Association, and I'm very excited here to give the stage to Pietro, who I met recently on a Twitter discussion, and I quite like the ideas that Pietro was putting forward related to governance. So I invite him to join us here and share a little bit about his work. Pietro, if you like, start with an introduction, and then the floor is yours.
Thank you very much. So yes, my name is Pietro. I have a background in math and then in bioinformatics, and eventually I started being interested in governance of the future. I mean, how decision making could work in the future. That started about 15 years ago, like in 2005. That's 16 years ago. You all know the phrase every generation has its own revolution, and I was actually thinking about that phrase and thinking which one is our revolution. And at the time Wikipedia was just starting, and I thought, well, probably our revolution is a technological revolution, trying to set up systems, um, set up system that governs and that cannot be, manipulated by the powers that be, so to speak. And in the years I've joined several groups. I had various ideas which grew partially in me and partially with the interaction with other people. And it would probably take too long to just go through the curriculum of everything I did. But some of those ideas, I will present them here. Okay. Through the years, I developed several solutions for decision making, and in particular for online decision making. And I'm going to present some of them. And actually, it's in my personal life, I'm actually a Taoist, as in the Chinese religion, not just Tao. We're all Taoists because we want Taos. And one of the things I learned through Taoism is always to start with the simple thing. And then, because if you have some simple and middle and a hard thing to do, if you start with the simple, by the time you've solved those, the middle will have become simple, the hard will have become a middle, and you can continue always doing the simple stuff without making stupid mistakes. So this is actually what I will do. So I will start with some very simple but also really important solution that I think Aragon should implement. And this is in a sense like the low fruits, and then there are other fruits that are beyond that and other fruits that are beyond that, but I won't be able to present all of those in a single hour. So in case if you're interested, we can set up other meeting or something like that. But I really believe into giving you a tool with everything that comes with it, so that you really can use it after that. Here are various solutions with a date. The date is pretty much when I was working in that. Some things are missing. You see there is a jump between 2009 and 2018. I was working, but I just was working in other things still related to governance. And some are older theorems like voting on a number and Condorcet Winner and so on. But we need to go through them. And so let's start with the beginning. Suppose that you need to take a decision among two options. So, shall we do A or shall we do B? Or shall we do A, yes or no? Something like this. And there's a number of people that need to take this decision. Then the possibilities are usually just you could have either an absolute majority on one, 51%, 80% or something like that, a qualified majority, which is way more than 50%. Maybe you say, we want at least a 70% or at least 80%. Or you could have a consensus where everybody agrees, or you could have a consent. Now, what is a consent? A consent is something really, really important that you will find that is used quite a lot in systems around. For example, Sociocracy tend to use it a lot. In Vilfredo, which is a system that I developed, we used it, and other systems also use it. And so the next slides will be devoted to describe the difference between consensus and consent and a normal majority, because I think this is really, really important for what you're doing. And if you have a normal consensus system and you say, let's have consensus on this, what you actually mean is, do we all agree on this? And basically, when there is a decision, the possibilities are just three. Either you agree, or you disagree, or you are pretty much neutral. And to be consensus, to be on the boat, you need to agree on that. Okay? But now the consent is different. In the consent system, is there a question or something like this? No. Okay. In the consent system, anyone who is neutral also consent to it. Now, this is really important. I mean, I might not like to go to the sea, and my kids might want to go to the sea. I don't care. The babysitter might bring them, the mother might bring them. I consent to that. I'm not like, yeah, let's all go to the sea, but it's okay. They can go. At that point, disagree becomes some sort of a neutral. Yeah, I disagree, but I'm not really going to stop you. And then veto is exactly the opposite. Veto is, what you're doing is so much against my values that I will do what I have in my power to stop you. Vice versa, on the other side, you also have a division between agree and support. Agree means, yeah, I want this to happen. Support means, I want this to happen and I will help you. This can be monetary support, can be a support with time, I can be a support with a network of friends or something like that, and so on. But those five possibilities, if you think about it, they are pretty much present in any decision. And, kill the rich, veto. Why? Well, I don't think killing is a good reason, and so on, and so on. So now let's make an example to really understand how those two systems tend to work in a different way. Let's suppose that we have 5 people, Angela, Betty, Claude, Diderot, and Eve, and they are A, B, C, and D, A, B, C, D, E. And there are 5 issues, and each of them has either support for some, or disagree, or approve, or veto, and so on. And so Angela supported the first and basically disagree with everything else. Betty supports the second and disagrees with nearly all the rest except for issue 5, and Claude. It's quite symmetrical, the system. Now, if people vote in a normal voting, you would actually get that the first 3 would be rejected because they have a lot of disagree and veto and only one person supporting it, whereas issue 4 and issue 5, they actually would pass. That's what we would expect to happen. But now let us suppose that the day before the meeting, once we all know what the proposals are and who is going to be voting and so on, Angela, Betty, and Claude meet, and they just meet at the station and say, let's go and have a pizza. And so they go and speak with each other in the evening, and they kind of decide to help each other. And so they basically, at this point, are going to become like a single unit. whereas inside this unit, they're going to use consent, and outside, they're not going to consent anything if they don't really care about it. So this is how it normally would have been. We've seen how it normally would have been, which is this one. Now, in this new version, what do we have? We have Angela that says to Betty and Claude, if you accept to support me on issue 1, I will support you on issue 2 and issue 3. Now, this is something that happens very often in governments when you have several parties that join a government. And not only, I mean, sometimes you call it, in Italian, it's called voto di scambio, exchange vote. I help you on something, you help me on this. I scratch your back, you scratch my back. There are thousands of ways in which this is called. And it makes sense because from their point of view, we said a disagree in a consent system is not such a big thing. It doesn't really go against your deep values. At that point, they can easily consent in exchange to have this thing which they really support pass. And Diderot and Eva, which actually wanted the veto over this because it was really against their values, they vote reject, but they are overrun by Angela, Betty, and Claude. Whereas the opposite happens on issue 4 and 5. On issue 4 and 5, they all decide to disagree. And so basically, only Diderot and Eve decide to agree on this one, and they get rejected. And those two. So basically, we are able to get a completely opposite result simply because 3 people decided to speak between them and to reach an agreement before, which is something absolutely acceptable in every democracy. I mean, that's not just something that is acceptable in democracies, but is very often the base of parliamentary democracies. I mean, in Italy, the only way in which a government is done is if a number of parties join together to support the government. And they are pretty much saying, we are going to help each other to pass the laws. And only at that point does the president of the Republic offers the government to a representatives of this group. I mean, actually, it's the opposite way, but the president of the republic first checks if there is the majority, then offers to start a government, and then the government checks if there is this support, and so on. So this is something that is considered very, very positive in theory. But I don't see it as positive at all. I see it as a dictatorship of the majority. A dictatorship of a fixed majority. Why I rise this up right now when we speak about DAO? And I'm very happy that there is a person who is involved in the user experience in Aragon because this is really important. For the first time in history, maybe for the first time in history, forgive me if I went further, it is possible to create systems where this is not possible. Imagine if Angela, Betty, Claude did not have the possibility to meet each other before. They simply did not know who were the other people involved. Either everybody was anonymous or, there are so many people voting that you are unable to make them join and you're unable to create a party or something like that. Now, something like this in a normal voting system is not possible. But in an online voting system, it is possible. And so it is possible to actually put back democracy where democracy has been taken out. And it has been taken out by creating a consent system out of a subgroup of the whole group. With this, I'm not going to say that consent systems are bad. it is absolutely acceptable to have a group of people that that decide to work through a consent system. Each person who participates has veto power. That's fine. If they decide it from the beginning, that's absolutely okay, and that's great, and that's a wonderful system. But what I suggest is not such a wise idea, and it would be really good is if DAOs were able to create systems where it was not possible for subsystem to make an agreement between them and then impose their will over the rest of the group. And this is possible now with modern system, because modern system can decide the flow of information. Now, this thing about deciding the flow of information is not something I will speak very much about right now. Is something I would actually I'm not going to speak about in this talk. Is very much something in where I would like to speak if on the most advanced part, where artificial intelligence as a moderator and so on. But those are things that you can already start to implement in some ways. I mean, who knows who participates? Is it just the system that knows it? Is it totally transparent? Sometimes it is good to have a system that is transparent. Some other times it is good to have a system which is not transparent during the decision making, but not transparent to everybody. It's not that, moderators or the chief of governance or the chief of user experience have access to that. No. Nobody should have access to that. It should be cryptographically impossible to get those information. And then after, get access to all this information. I mean, you can make a system which is non-transparent before, but transparent after. Okay, and this is one of the key messages that I want to pass. As you're designing system for Aragon, consider this. Consider this as a possibility, because it might really change the way decision making works. So I'm gonna skip this slide. And by the way, I hope this watcher is okay. If I die, please share my message. So consent scales better than consensus. To get a system that have consensus, you need everybody to be on board. To have a system that has consent, where everybody votes as consent, which, as I said, by itself is a good system, that scales better. I spoke about a system which is called Vilfredo. I'm not going to present about it, but it is a consent system. That system was used in jails in Costa Rica, and they were able to reach a decision among, I think, 50 women inmates on the question, what would we like to change in the jail? And what they all voted for and they all consented to was, we want the guards to treat us better. And if it was a consensus system, they probably would not have reached this result. This was 50 people. So it's not small groups of people, 5, 10 people, and so on. Second, many voting systems end up as a consent system. Even if you don't have a consent system, if you have a majority system, you must pay attention, because you might end up creating a consent system in smaller groups, and which then implies a dictatorship against everybody else, which is then pretty much captured as an hostage, because they have no decision power anymore. And so those consent systems are more common than you accept. But it's okay to have consent system from the beginning. So if you need to vote using majorities, which I understand is what most people do, try to make it in a way that people do not know who the other voters are, or do not know what the other voters are voting at in that particular moment, and so on. And I know this is not always easy, and it's not always an easy sell, but this would actually improve actual democracy. So we spoke about, and this I said, online community is the first time where this is really possible. So we spoke about a type of outcome when you have two options, and we had consensus consent and qualified majority and absolute majority. But what if you have multiple options? Just a moment ago, we had Angela, Betty, and Claude, and so on, picking on 5 options, and each option had either approve or not approve. Suppose that you have 5 options, and you only want to pass one of them. Maybe you have only the money for one of them, or you want to pass one and then decide. At that point, other possibilities arise. One of them is a qualified majority. One of them is Condorcet Winner, and the other one is relative majority. Now, relative majority is absolute majority means a majority over 50%. Qualified majority means a majority much more than 50%. You decided before, can be 2/3, it can be 3/4. You know, your people are voting the Pope, they must have 2/3 and so on. Well, now it's not like this anymore. It used to be like that. And then you have Condorcet Winner. Now, as I used to do with my students, how many people here know what a Condorcet Winner is? Please raise your hand.
Pietro, so unfortunately we don't have the possibility to raise our hands here.
Okay.
But,
You don't have hands.
No, we're just online, quite anonymous at the moment. But I would imagine that at least 2/3 here are not familiar with the concept. That would be my guess.
Okay. Perfect. No problem. And so we are going to speak about Condorcet Winner. Just for you to understand the field that studies all this, also if you want to go deeper in this, is called the voting theory. And what we are speaking right now is single winner voting system. Then you have multiple winners voting system, where it gives you an ordered list, or it gives you the first 10, or you gives you an A team, no connection with the TV show, and then when people vote, there are different kinds of voting. People can vote with the best candidate, and you all know these forms of voting is a really terrible form of voting. We all know, where you just say one candidate. You know, there are 5 parties or 7 parties. I only have to say one, and everything else is not. I cannot say it. Another possibility is if I say all the acceptable options, or if I say an ordered list of all the options, or if I evaluate all the options by a number, or evaluate all the options by an adjective, like fair, good, insufficient, terrible, and so on. And these last two are actually not equivalent. If you buy the book about majority judgment, the first chapter is about it. It's very, it's really convincing, I have to say. The second one is the one that you use for approval voting, which is quite common because it's a very good voting system, which is simple enough for people to use it, but gives a fairly good result. But now I want to really speak about Condorcet winners. And thanks to Jérôme Lang for the slides. Jérôme Lang is a professor at 2 universities, one in Toulouse and the other one in Paris. And we've been friends from 2009, when I took a course in voting systems from him, and we've collaborated and so on. He's a great guy. And so he has those wonderful slides, which I just use in this case. Now, let us suppose that we need to to vote a candidate, and this can be a candidate as a person or can be a candidate proposal, and there are 5 possible proposals available: A, B, C, and D, and E, and you have 33 people who prefers A to B to C to D to E, 16 people who prefer B to D to C to E to A, and so on. So now I ask you, who should be elected? And now plurality voting, which is the one everybody knows, where you just ask people to vote their best candidate, would have voted A, because 33 people wanted A, 16 people wanted B, 8 plus 3, that makes 11 people wanted C, 18 people wanted D, and 22 people wanted E. Borda, which is something that assigns scores, gives a 0 point to the last one, 1 point to the second last one, then 2 points, then 3 points, then 4 points, would have had a winner B. If instead you use a veto, where you give negative points to whoever arrives at the end, a sort of anti-approval, then you have 3 pre-winners, B, C, and D. And if you get a 3 approval, where you just count the first 3, then the winner is C. So there are different forms of voting, and each voting system, by the way, when you study it, you think about it and you go, this is really good, I really think we should vote on this one. And then you read another voting system and this is actually better. And so it's kind of interesting, the fact that you can find cases, and those cases are rare, but not completely rare, not impossible, that gives different results. And so how does Condorcet system works? Condorcet works by looking at all pairwise. What does a pairwise? For example, I want to know between A and B, how many people prefers A to B and how many people prefers B to A. And if I look at how many people prefers A to B, I have 33 here. And that's it, which means that I have 77 people that prefers B to A. So B has an arrow from B to A, means B is preferred over A. So they actually compare all pairwise possibilities, between A and B, between A and E, and so on. And if you have something from which all arrows goes away, it means that this element wins all pairwise comparison. So if you compare C respect to A majority of people wants A. If you compare C respect to B, a majority of people prefers D, and so on. So a Condorcet system is a system that, if it has a solution which has this property, and this is called a Condorcet winner, it would elect this system. So wait a moment, does this mean that not every system will have this not every system will have this property? No, not every system has these properties. In fact, if you change just this one, so from instead of A over B over C over D over A, you move it from A over B over D over C over A, now D ends up being better than C. And now you have what is called a cycle, because C is better than B, D is better than C, and B is better than D. So even if you cancel A and E, you remain with a cycle over here, which is B, C, and D. And so this is called, I think, a Condorcet cycle, but I'm not really sure. In any case, is a cycle, and is the reason why we don't just use Condorcet systems. When there are many Condorcet systems, and there are differences what they do in case of cycles. But generally speaking, if you can find a Condorcet winner, and it's not always the case that you can find a Condorcet winner, but if you can find a Condorcet winner, then that is considered a really good system. Okay. So takeaway message is sometimes there is no Condorcet winner. When there is a Condorcet winner, this is unique. And a voting rule is Condorcet consistent. So this is one of the properties that voting system can have if it outputs the Condorcet winner whenever there is one. Okay. And so now you know what a Condorcet winner is. And now the question is, if we are setting up a system, what kind of agreement should we try to reach for? And oh, by the way, so what is the best voting system, just in general? This is a list of several voting systems. I found this from Wikipedia. And approval, board account, Copperland, Kennedy Young, which is a Condorcet system, min-max, plurality, and so on. And this is those are all properties. So Condorcet is the Condorcet property that we've seen now, and each of those is a property. Each of those is something that you want to have in your voting system. And as you can see, there is no line with all green yes. Just from this table, you know that among the voting system that we know of, and in fact you can prove that it's in fact impossible, there is no voting system which will have all the properties. So just relax. We are trying to mitigate the damage here. We're not trying to get the perfect solution. But what are we actually trying to reach? If you have a few people, maybe you can try to look for a consensus. I mean, in a family, you normally try to find something that everybody agrees and everybody wants. If you have, a team, maybe you will go for a consent. But what about the rest? Can you actually say, for example, that having a qualified majority is harder than having a Condorcet winner, and so on? Well, actually no. Actually no, because there are some theorems that says that if you have a voting system and you have as the number of participants grows, the probability that there is a Condorcet winner as opposed to a Condorcet loop increases. So it's actually easier to make a system. If you have 5 million or 10 million people voting, the probability that you actually end up with a Condorcet winner, it's actually not that high. You also have some difficulties in calculating the Condorcet winner with 10 million people voting, but that's another details. But it's still possible. I mean, with computers, you can do it easily. Okay, and something else, the technique matters. And when I speak about the techniques, I'm not actually referring to the counting system. No. Keeping the counting. Actually, there is something else that is not very much considered within a voting system, and that's one of the things on which I'm working on in a sense, and that is everything around. We've spoken before about how if people are allowed to speak to each other before a voting system, then they can create a subsystem that create consent. That's and in a situation like this, they can impose an absolute majority over everybody else. This is the kind of techniques that I say, the user experience, the way in which you interact with the people, the kind of information that is shared. All this is part of the technique. And this is something I am very much working on, even though I'm not a user experience guy. So what is the classical DAO question? Well, the classical DAO question is, what shall we do about blah, blah, blah? And you have multiple proposals, usually are more than 2, and usually the number is not limited. In fact, a new proposal tend to come with time if you wait. And you can have many winners. What shall we do with this $1 million that we gathered? Okay, so now we have a proposal to do this with 100,000. Okay, what shall we do with the remaining 900,000, and so on? But we can start with a single winner and then make a second vote and a third vote. And uh, and there is a need to reach the result. I mean, you actually want usually to reach a result. And we want as strong an agreement as possible. So if it is possible to have a consensus, it's good. If not, a consent is okay. If not, a Condorcet is okay. If not, and so on. And I'm not going to tell you about this. I'm not going to tell you about this because this is going to take 1 hour all in it. Instead, I'm going to tell you about something else, which is even more important than this, even if you are not going to believe this before, but you will in a second. And it is another question that DAO have to face even more often and they don't realize to. And it is, how much shall we? How much? And this is, it happens so often. You gathered a lot of money. You need to decide how much do you spend it in this particular project, in this particular endeavor, how much. And so is a question where you have any number. We are looking for a number. And we want one winner, only one number. And there is still the need to reach the result. And there is still the need to reach a very strong agreement over there. And so here we go, and it's called voting a number. So here are the requirements. Suppose that you need to find a number on a one-dimensional line. This is not for 2 dimensions. This is one-dimensional, okay? So it's just one-dimensional. And then let us suppose that each person has its own preferred value. So I ask John, he knows its own preferred value. I ask Daniel, he knows its own preferred value, and so on. And then we ask that each person preference is single-picked. I'm going to explain soon what single-picked is, but basically means as you move away from this value, people like the result less and less and less. So if this is the solution, what happens now? I don't know if you heard this. Let me run it again because, oops. Okay, the result is there is a Condorcet winner. Wonderful. And not only this, it's not just that there is a Condorcet winner, it's also that it's easy to find it. And to find it, you just need people to vote in an easy way. We've seen before different ways of voting where people would, order all the proposal and no. This is going to be a very simple way of people to vote. And yet we are going to be able to reach a Condorcet winner. And this is called the theorem of Black. So you can look it up. It's called the theorems of Black. And how does it actually work? And I'm not going to go to the proof that you can look it online. And first of all, what does it mean that it's single picked? It means that each person has one value that they like more than anything else. And as it goes away from that value, how much they like the result is monotonically decreases. And to tell you the truth, I don't know if the theorem requires that it is monotonically decreasing or strictly monotonically decreasing. I think even just monotonically decreasing it's enough, but I'm not sure. So this is the peak of this person. So you see how much he likes the various results. Another person will have a peak here. Another person will have a peak here. But you do not find anybody who has 2 peaks. One peak here, then maybe it goes down, and then maybe it goes up again, and then it goes down again. No. This is not the case. And if this is the case, then it's very easy to find a Condorcet winner. And how it's done, you ask everybody to vote for their preferred value. And you take the median, not the average, the median. You take the median of all the preferred values. And magically, the median of all the preferred values is the Condorcet winner. So think about how incredible this result is. You have an infinity of possibilities. All the continuous between 0 and 1 or 0 and 10. You have 1 over pi. You have 1 over e. You have 2.73425. You have everything inside, and yet you are able to find a Condorcet winner just by asking everybody what's their preferred value is. This is amazing. And so here is an example. Let us suppose we want to buy this Lambo, and the DAO wants to buy this Lambo, and everybody gives their evaluation and see this is how much the DAO as a unit vote. This is not, this we are not asking who is bidding higher. This whole group is one entity, and they're saying we are bidding 7.3 to buy this small Lambo. And I don't know 7.3 of what. 7.3 Bitcoin is probably too much, but 7.3 of other crypto, more obscure, might be maybe 7.3 Dogecoin might be okay. So how does it actually work? Not the theorem. How does it actually work? I mean, is the result a good result? Yes, we reached a Condorcet winner, but is the result something that we can be confident that it's that the result might is as good as an expert would actually evaluate? I mean, what those people evaluated this car is what a group of experts would also evaluate it, and the answer is yes. And the paper that came out showing this this answer is the paper from Francis Galton in 1907. And from that moment in 1907, actually, the number of papers that came out about this have been hundreds. I mean, they're really, this is a vast, and it's called Wisdom of the Masses, and so on. And there are a lot of details, but basically this guy was walking in the countryside, and we came out in a situation where a lot of people were bidding on how much an ox weighted, and those were people in the countryside. Each person gave their own evaluation, and whoever would come closer would have won a consistent amount of money. And so they had an incentive to really try to reach the result. And this is important. There must be an incentive. And when they voted, the guy who was actually a mathematician, and he actually did not believe in wisdom of the masses, he actually was an elitist. Remember, here we are before even World War II. So, the idea that there are a group of enlightened people and a group of less enlightened people, it was just what a lot of people believed. And this guy, even though he was an elitist, he actually had the intellectual honesty to realize he was wrong and write this paper and showed that actually in this case, I don't know if both the median and the average were really close to the actual result. And now some of the experts, I think, might even came closer than the median and the average. But a lot of results came later and found out that if you have a system like this and you have like 20 experts, now the 20 experts will be around the result. Will be around the result. Whereas the median of this will always be very close. So some expert will be as close as or even closer, but you cannot predict in advance which of the expert will be so close. So you cannot actually use this. So this is actually better than asking one expert or even asking a team of experts. And you can test this very easily. I actually did this. Just go to a coffee shop or something like that and ask everybody in the room how many sugar cubes are in something like this, or how many beans are in a bag or something like that. Show them the bag, show them the container, and sign the number. If it's even better, don't make people hear what other people have voted. That makes it even better. And then make the median, and the median will be very, very close to the result. I've actually tried this and it actually worked. The median was somewhere around, it was actually 30 and the number was 28 or 32. And actually, it's also interesting that it reaches the median very soon, and then it tends not to change anymore. I've tried this also in a number of occasions, like for example, asking to some friends how much should politicians be paid, and it came out some 4,000 euro per month, which is unacceptable. It's a good, not zero and not an incredible. Something else. And then in Italy, they wanted, we have now a limit over how much money can you pay in cash, and everything else have to go through a bank so that people don't avoid paying taxes. And so I asked that also, and that also reached, I think, something like 5,000 euro. And it was interesting how soon the median result was reached. I asked some 20 people, but within 5 or 6 votes, we've immediately reached the median has already reached a system that doesn't move anymore. So what's the problem instead in voting the average? The problem in voting the average is that a single person can screw up the result a lot. I mean, if I know that everybody is going to vote, or if I think that everybody is going to vote 30, and I know that there are about 100 people, and I want the result to be 100, I am going to vote 100,000. I'm going to calculate exactly how much I want to vote so that I move the average all the way up. So you have if people vote the average, you end up having the possibility to manipulate the result very, very much. So the result end up being very unstable. If you vote the median, that doesn't happen. If you vote the median, you have the best outcome. If you give your euro the vote that you really think of, I think the best is 50. I give 50. If the result of everybody else is 30, well, I pushed it up as much as I could. If the result of everybody else is 60, I've actually pushed it down, so it worked also. Whereas if I voted for 10,000, I moved it up. So it didn't work. Sorry, someone is trying to come here. Sorry, I am using the room. And let's move on. Yeah.
Can you hear me?
Yeah, Luca, tell me.
Yes. Hi, Pedro. This is super interesting. Thanks for being here. Just a quick question. So supposing you have, just going back to the example you were showing, supposing you have a sufficient sample size and understand kind of the average of your sample. I'm trying to understand how important the weight of the incentive is in the outcome that you've just mentioned, kind of to the standard deviation of the sample. So would you say that the stronger the incentive, the more the less important other factors of your analysis?
I don't know. I mean, I would suspect that in a DAO where people manage money, the incentive is already in the fact that the DAO should not screw up. Whereas if you want to use this into something else, like DAO Court, which is going to come in a second, then yes, you need to put in an incentive. And at that point, the problem is that to have the incentive and the ox, there was an objective truth, and the same thing in the number of of cubic of sugar cubes. Whereas if there is no objective truth because we are deciding how much to invest in MicroStrategy, there is not perfect result. Nobody can tell, oh, this is actually what you should have done. At that point, I don't think you can actually set up an incentive like that. So yeah, this is something on which we should think about it. I don't have an answer right now, so I'll
That's
think
very
about it
Thank you.
for another time. And I don't want to give you a fake answer or something like that. One of my
No,
things as a mathematician, and that it has been very frustrating for people working with me, is that I refuse to give answers if I don't have it. Which sometimes in Vilfredo we needed to wait 7 years or no 5 years before I added comments because I just didn't know how to put them without screwing up everything.
that's a very pragmatic approach. I like that.
Okay, let's move on. So
Pietro, I'm kind of gutted
now some
to.
Aragon questions. How much should we invest in? A lot of DAOs are, like the first Ethereum DAO, you will remember, and others are actually handling money. We pool this money together, and then together we are going to invest it into something. So how much should we invest in? Now, what should we invest in is another question, is the other question. I spoke about it before. But once we have decided what we should invest in, now it comes the how much we should invest in. And another
Pietro,
question is how much, yeah?
if I may, because we scheduled for an hour, and I'm very, very sad to see that we only have 2 minutes left. I think everyone is loving your presentation, and there is definitely a lot more we would love to cover with you. So perhaps we could do another session. Would that work for you? And then we can cover some of the other things. Like personally, I'm very, very eager to discuss Wilfredo with you and some of the other more advanced methods.
Okay,
But
can I have the 5 minutes we lost at the beginning and then yes for the
absolutely,
rest?
it's a
Okay.
deal.
So how much should we invest? How many people? Now, other question could be, we want to have a team working on this. How big should the team be? The latest part of this talk was unfortunately not recorded. So in the next talk, I will start back from the application about voting a number. Thank you very much.